Welcome back to Microsoft Virtualization for VMware Professionals Jumpstart. I'm Simon Perriman, Microsoft Technical Evangelist and VMware Certified Professional, and I'm joined by Matt McSpirit, Technical Product Manager and also a VMware Certified Professional. Now, in this module, we're going to be talking about application management. So up to now, we've kind of showed you the core infrastructure, built it up by now introducing System Center 2012. We're going to spend quite a lot of time in this module really focusing on our differentiators within our application layer as far as deploying, configuring, monitoring, and operating these applications.
Yeah, and that's a good segue. We've got a great amount of capability within WinServer 2012 to provide the foundation from a Hyper-V perspective of virtualizing your core apps. But what I want to help you understand in this module is how we can help you get the best out of those apps and change the way you deliver applications within your environments and move away from thinking of just VMs as blocks, but think of them more as services that can be delivered into the environment and streamline the way we deliver virtualized applications. This is section 6, so this and then 2 more, and we've gone through all of System Center and Hyper-V at a decent level of detail, but obviously these components are so vast that you could spend a day on each one. So we are only scratching the surface with what we covered today, particularly in the System Center arena and how it compares and contrasts. But this module now, as Simon said, it's going to be a little bit longer. We've got a lot to cover that focuses on app management and maintenance and protection, with the main bulk of the content being in these first 2. So helping you construct, deliver, and consume applications, but also help you maintain and manage them once they've been deployed and put lifecycle around that as well. Before we focus on constructing, delivering, and consuming applications, we touched on earlier around clustering, and we talked about how we can go through multiple steps to deliver a cluster within Windows Server, within the interfaces there that we demonstrated. But I think it's worth looking, just before we focus on delivering apps into the virtualized environment, apps, virtual machines, and services, it's probably worth having a quick look at Virtual Machine Manager and how it can simplify how we deploy Hyper-V hosts and cluster them, and how that compares and contrasts with the Hyper-V infrastructure that we showed earlier on. And that will be, for the VMware guys, probably a little bit more analogous with what they're used to with vCenter, clicking and dragging different hosts, building clusters that way, and deploying clusters deploying hosts from a central source like auto deploy, for instance. So do you want to show that?
Sure, we could jump in.
Okay, cool.
So if we switch over to my management interface, what we have up here is System Center Virtual Machine Manager 2012. So this is a live environment that I'm running here. And I've already gone and deployed a few things, but I'm kind of just going to walk you through what are the basic concepts, what's the kind of look and feel, because guess what? You can also download the eval of System Center 2012 Service Pack 1 today, and you get Virtual Machine Manager if you want to try that out yourself. So first thing that we look at here are the virtual machines and services. And Matt's going to spend a little time later talking about the composition of a service, but essentially it is a collection of virtual machines that we can manage as a single logical unit. So we realize, virtual machines, it's usually an application isn't just in one. We often see a front-end web server, back-end database, middle tier for integration or business intelligence, and every time you deploy this app, you deploy all 3 tiers. And so using this concept of services, it gives us better automation, better management, and better insight into how this application is performing as a whole, rather than just that one component of it, that single virtual machine. So under here, I could take a look at my VMs and services. And so right now I have a couple of hosts that are deployed. I have physical servers that I'm connected to, some virtual machines, and then we have this concept of clouds. Now, a cloud is essentially a management unit that we can use for our resources. Now, if you think about this concept of the private cloud, one of the key components is pooled resources, where we can put together all of our storage, networking, servers, all of these resources which we want to use in our data center. And with a cloud, we can essentially carve it out into a smaller unit. So we see clouds used in several different ways. One example is breaking up clouds by geographies. So if you have a data center in North America, Europe, Asia, you might want to allocate the resources for each of those data centers within those 3 clouds. This way, when you're managing different servers, you're always managing it locally. Now, one great example is if you're deploying a virtual machine from a library. You might have a library server in North America, Europe, and Asia, but when you're copying a 50 gigabyte VHD file, you want to do a local copy within that data center. You don't want to be copying the file from North America over to Asia. So by breaking it up into clouds, you can assign resources, assign capacity for all of those different units. Now, you have the ability to configure different logical networks for clouds, different load balancers with built-in support for many different types of load balancers, including Windows Server Network Load Balancing. We can connect to our different library servers. And one of the best features here is capability profiles. And what you see listed under here are 3 different options: the ability to manage Hyper-V, Citrix, and ESX servers. And so within a single cloud, I can actually manage all 3 types of virtualization hosts. And using this capability profile, I can say when I deploy an app, which servers are eligible to be deployed. So even if I build an application here and I want to go run it inside a virtualization host on VMware, I have the ability to manage that and deploy that using Virtual Machine Manager. Final component I'm going to show you here is our capacity. Now, when we think about a cloud, we're aggregating resources, and we can assign specific user roles to access those resources. But in many cases, we want to put some limits on there. We don't want some rogue engineer deploying an unlimited number of virtual machines where he doesn't clean up afterwards and ends up using all of the resources. So using these capacity limits here, we can actually assign maximums, different limits, to ensure that people are using this cloud correctly and not over-consuming resources. When I click on the fabric, I actually have the ability to manage all of my physical servers here. So I get a list of servers. Here you can see I have a cluster that I'm managing as a single unit. I can run cluster validation. So if I want to go test my cluster, launch that failover cluster manager tool, have that ability. But also through here, I can manage my library servers. So these store my VHDs, ISOs, templates, other components that I may want to reuse and deploy in my infrastructure. I have my Pixie server that I'm going to use for booting if I want to boot during deployment. I have update servers which can integrate with Configuration Manager, Windows Server Update services. I have vCenter servers as well. And a little later today, you're going to see me manage a vCenter cluster straight through Virtual Machine Manager. And then, of course, my VMM server. Under my networking, I have the ability to manage all of my networks from a single place. So we could start with a single logical network and break that into groups of IP addresses. Subdivide the network so that I can allocate IP addresses for particular resources. Under storage, I have different arrays, different classifications, and different providers that I can configure as well. When I jump into my library view, again, library is where we collect and store all of our information. I get access to all my different templates. So I have templates for a particular virtual machine, and then I have templates for this service. And I'm going to let Matt touch on the service in a little bit, but again, this is the aggregation of all these individual roles. We then have the concept of profiles, and profiles are essentially a pre-configured set of information that will go in a virtual machine. So if I want to deploy apps within my virtual machine, I can build templates for those. I could build templates for my guest operating system, looking at things such as what type of OS we're going to install, integration components, administrators, passwords, user roles, time zones, so we can pre-configure all of this. With our hardware profiles, we have the ability, here's a quick example of our guest OS profile. Oh, and one thing that I can't forget to mention, of course, is we can pre-configure all of these different Windows Server features and roles in this template. So when we actually go and deploy these VMs, we can have all of these roles pre-enabled for us. The hardware profiles, we have the ability to specify the hardware settings for this particular virtual machine. So as we look at these, we get access to the same group of Hyper-V settings with processors, memory, all of these different devices. SQL Server profiles give us the ability to manage our SQL instances. Now, there's a couple other additional libraries here where we could tie in with Configuration Manager for patches and updates. Now, next view is the Jobs view. Under our Jobs view, we could do things such as see the success, see how actions that we've created, whether automatic or manual, how they're running. And then finally, we have access to our settings. This is where we can configure different accounts to use, different properties, and connect to our other System Center resources. So once again, Matt, I answered this question earlier, but I'll bring it back to you. When should people start thinking about using System Center Virtual Machine Manager compared to just using the core Hyper-V Manager?
Good question. I think there are certain capabilities that are, and we'll address shortly as well when I take a look around VMM and expand on what you've covered already. There are certain capabilities within VMM, such as the advanced deployment at scale, the management of lots of hosts, I think certainly becomes more manageable with System Center Virtual Machine Manager. If you want to start to deploy VMs more quickly, so for instance, there's no templating process in Hyper-V on its own. If you want to be able to build the templates that you alluded to and that I'll cover in more detail, those are specific to VMM, which means I'm going to need that if I'm provisioning templates or VMs more frequently for whatever reason, test and dev or deployment of new apps or whatever it may be. So there's lots of little individual reasons, but on the whole, it gives a more complete management experience. And also, it gives us a bit more automation associated with some of those tasks as well that would be a little bit more manual in Hyper-V.
Now, I think one question that's come up a lot is, do we have an equivalent to DRS, Distributed Resource Scheduler? So do you plan on addressing that later? Or
I was going to show that when I go into VMM. Yeah, I was going to show that after.
Well, let's save that for a little bit. But the question I've seen probably at least 10 times already is, can we dynamically move around virtual machines based on the underlying storage, network, CPU, memory? Absolutely. That's fully integrated into the solution, and we'll cover that feature in a bit.
Yeah, that's right. So if we go back to the slides, what Simon's covered there is a good introduction into VMM, and we'll delve into it in a bit more detail, and we'll look at as well how we can do some bare metal deployment within VMM as well, which would be pretty cool to show you how we move on from our what we discussed earlier with clustering. But I want to show you a bit of an art of the possible demo of the kind of thing you can achieve when it comes to service delivery and delivering these applications. Simon introduced a number of terms, cloud and services and VM templates and so on. And I want to give you a quick demonstration that builds on some of that and aggregates it together in such a way that will hopefully tell a bit of a story, and then we can start to delve in a bit more detail into some of those. So let's duck into my demo environment and let's look at this particular one. Now, in this particular demo, what could be more mission critical than an application that manages our expenses? Absolute mission critical. Top of the line in terms of, we need show me the money. If I've paid out of my pocket for some coffee,
I want it back, right?
Yeah, I'd like it back. I'm collecting all my cups and stuff. Anyway, I'm going to play the application owner in this sense. So I've got a vested interest in Expense Manager. I own it as an application manager. I'm not necessarily the infrastructure manager, but I know that this application is running on the IT's infrastructure. It's just all I'm interested in really as the app owner is this expenses application. And you can see that it's working pretty well. If I click in, we'll see there's lots of useful information in here, some of it a little bit dated, but it gives us the application's working and functioning. But let's have a look at what actually provides this infrastructure. And what I've come over to here is that app controller front end. An app controller, as we said before, is that component that enables me to consume cloud resources, and it's aimed exactly at that application owner. It's not aimed at that person who's interested in the nuts and bolts of VMs under the covers and storage and SANs and networks. It's that person who wants some space to run their stuff. An app controller, it's integrated, it knows who I am, so I've logged in as Ryan in this case. I'll just use my little Zoom tool. It knows who I am, and therefore it knows what to expose to me. And in this case, I've been exposed to a single cloud. Sounds worse than it is. I've been allocated in a single cloud. And this cloud is my pool. So IT have aggregated all of the resource, the fabric, some of the things that Simon was alluding to before, and all they've given me is a slice of it. And Simon showed some of the properties of a pre-created cloud, but what we'll do later on is I'll create a cloud from scratch and show you what we do from there, how we allocate users to that cloud, and then how they access it through App Controller. But in this interim, I want to show you, like I say, a bit more of the art of the possible. So I've been allocated a cloud. It's got a certain level of, let me just zoom back in there. It's got a certain number of virtual machines that I'm allowed. Currently running 3 from unlimited, so I'm pretty flexible there. But the number of processors I've been given in my cloud, 28, 426 gig storage, and 7.3 gig memory that I've got left over. So I've got a fair amount of resource that's available to me as part of my cloud, which is a good thing. But let's drill in and let's look at these services. So this is what Simon was talking about earlier on. What is a service? Well, a service is essentially not necessarily a single VM application, but it's usually something that's a combination of VMs and apps working in harmony to provide a service to the business. So Expense Manager, if we drill into it, you'll see it's actually made up of multiple tiers. So it's got a SQL tier, it's got a machine tier that's the application tier, and it's got a web tier. So that is a 3-tiered application, 1 VM per tier in this case, all connected to a single network, and that's what makes up Expense Manager. So we've deployed this service into a cloud, and we're currently using 3 VMs worth of capacity. And that little icon there with the blue and the little cloud there is indicating that this is an on-premise System Center VMM managed cloud that App Controller is presenting here. This one, however, is saying, okay, this expense version of the application or the service is actually running in Windows Azure. So as the application owner, I may have applications existing in different places, but I'm being able to aggregate them into one view. So I can have a look at the Azure instance, and I can also have a look at, in this case, the on-premise instance as well. So let me go back to let me go to this little application here. Because what this is, we're in the process of testing this application. So Expense Manager, we want to get it tested, stress tested. The user acceptance testing is fine. We want to make sure it's tested fully to scale, to ensure that it can meet the demand. So what we're going to do is use this very bespoke application we've built internally to just say, okay, let's ramp up. In fact, we'll do the memory, we'll do the CPU, and that's going to ramp up the load on this particular application. So it's going to really start to hammer it. Now, I could have hammered other things, SQL Server, I could trigger a server error if I'm looking for certain alerts, but in this case I'm just trying to apply load. Because what we've built in the background, Operations Manager is monitoring this. Remember we talked about OpsMan earlier on and how it's monitoring stuff? Well, in this case it's monitoring our Expense Manager application. And working with IT, I as the application owner have asked IT to ensure that they give me a consistent level of service. And that if that level of service is ever exceeded in terms of if there's so much stress on the system that it's not going to meet the desired level of performance, I would like them to take corrective action that automatically scales out this particular application of whatever tier is appropriate to be scaled out. So if we go over to OpsMan and we look at the dashboard here, we can see that we've got a view of the CPU and memory. So we've got a custom dashboard that we've built here, Expense Manager, and you'll see that the RAM is starting to decrease. We've nothing available now. The CPU is increasing in terms of utilization as well. So what we're seeing is our application is starting to suffer. But because we define that SLA, IT have actually written an automated runbook in Orchestrator that as soon as that alert is triggered, that Expense Manager is under intense pressure, the runbook is going to execute. It's going to start to communicate with other components within System Center, in particular Virtual Machine Manager. And what you're going to see in VMM is if I expand the tier here, we're already deploying an extra front tier for this particular application or service specifically. So what you're seeing now is VMM very quickly, through that automation with Orchestrator in the background, has taken that alert, it's run through the workflow, and it's deploying an extra tier. And if I go back to App Controller here, and I do a quick refresh, you'll see something's going on, deploying, instance count is currently 3. And what you'll find is in my clouds view, I've now changed to 4 virtual machines, a couple of processors, a bit less storage available, and I'm running out of memory. So that very quickly shows how we can combine some of the technologies, and we'll delve into some of these in a bit more detail, but that very quickly showed how we were able to scale a service. And if I drill into this, in fact, in a bit more detail, because what I want to do next, let's fast forward and let's assume that the application has gone gold. So our application, our Expense Manager, tested to perfection, everything's working fine, everything's working great. Now fast forward to the RTM version of Expense Manager, because that was a pre-test version we were looking at before. What I was talking about before when I mentioned service management, we've got a service offering here that relates to private cloud. And one of the requests I've got is I would like to request some private cloud infrastructure, because as the application owner, I would like some more private cloud resource now to deploy the RTM version of Expense Manager. So effectively, I'll have two clouds to finish. I'll have one that's used for test and dev and building pre-release versions of Expense Manager. I'll have one that's focused on the production. So I'll go to this request form. What do I want? What the capacity? Contoso production is fine. That's the cloud I'm looking for. What size? T-shirt size, small, medium, large. I'm going to go with medium. What recovery level do I want? So do I want 24-hour return to operation with 4-hour data loss? Or do I want something a little bit more efficient and a more granular and a bit more reassuring? Well, I'm going to go with this one. 8 hours return to operation, maximum 1 hour data loss. So this form that's capturing information from me, there's going to be different workflows that flow off the back of this submission of this form. They're going to configure certain elements of the infrastructure. Like it might configure DPM to start protecting any servers within this cloud. And any servers within the cloud will be configured to be protected every hour to ensure that we don't lose any more than 1 hour's data, for instance. I'm going to go next. I'm going to go submit. And that's been done. And Service Manager, as part of its ITIL-aligned incident change request management solution that it is, captures that, and somebody will get a request in their inbox, or they'll be monitoring the tool directly, and they're going to get that request that's going to say, okay, this person's asking for a cloud, do you approve, do you not? And as soon as they approve, the automation's going to kick in again. And let's fast forward and say that's assumed, that's approved very quickly. The orchestration kicks in, it creates me a new cloud for production, but this cloud currently has no services, nothing in it. It's empty, it's just a pool of resource that I can use. Well now, as that application owner, I can choose to deploy, and I can select a template, a service template, and don't forget we'll explore this shortly. And there's the RTM version of Expense Manager. We can see what it's going to consist of, how much CPU, memory, and so on. We'll click OK, and then I can start to configure each of these tiers individually in a more granular way and deploy. And what that's going to do is very quickly start to deploy that service into the environment, and it's going to give us a new service within the private cloud environment. There we go, so Expense Manager deploying, not quite ready yet, but that's going to take a few minutes. So that's deploying a 3-tiered application, so 3 VMs together with a single network connected, and before long I'll have an RTM version of Expense Manager deployed and ready to use. So that was very much an art of the possible type demonstration, showcasing just how we can move around and start to deliver that core infrastructure and those applications in a slightly different way. So it's pretty powerful. I don't know if you want to cover the bare metal deployment, or do you want me to do some more on?
Yeah, sure. I can certainly jump into bare metal deployment now. So we're going to switch over to my demo environment. I have a slightly different one than Matt here. And we're going to talk about how we can actually deploy a brand new server that's just plugged into our environment. So what we have back here is literally brand new server. Now we're going to plug in redundant network connections to our 2 NICs and redundant power supplies if your server supports that. Again, for high availability, eliminate any single point of failure. Now, all servers, they have on board what's called a BMC, or Baseball Management Controller. And this essentially interacts with some of the key system components like the disk, the network. It provides an IP address. And so you can get some basic operations and communication with that server before you actually install the operating system. And so what you're going to see as part of this demo is how Virtual Machine Manager communicates with the BMC using industry standard protocols to actually go and take this brand new server, install an operating system, and add it to Virtual Machine Manager. So what we're looking at right here, this is System Center Virtual Machine Manager again, 2012. We're going to go ahead and we're going to say add resources, and we're going to go and select a new Hyper-V host. Now in this particular case, I'm going to add a brand new physical computer here. Now I have to provide a run as account for security, so let me get my domain run as account. And here I get to select the protocol that I can use. I have the choice of using IPMI, Smash, or a proprietary protocol that we're going to use here. Now, next thing it's going to do is ask me for an IP address or an IP address range. And we're going to go talk to the BMC, the Baseball Management Controller. Now remember, I've already plugged in an Ethernet cable, and since I'm using DHCP in my environment, definitely a best practice for private cloud to eliminate IP address management problems, we could actually specify that particular IP address, or we could search for a range of IP addresses. And in this case, I'm going to go ahead and search for a range from 201 to 230, and probably most of these will come back with something that it's discovered. Now, in this case, I actually know it's .201, so pretty easy for me to select this particular one. Now, once I add it to my environment, I have the option of immediately adding it to a host management group, so I'm going to go ahead and do that, add that to my default. Now, on this next screen, I get to customize it. Now, even though I'm going to be using a standard operating system added to my environment, I still need to provide some unique identifying properties for this host. So here I get to provide a computer name. We'll call it Contoso Hyper-V1. I'm going to provide a MAC address. And then I have the option to provide the same IP address or use a new one. You know, maybe that DHCP automatically assigned one isn't what I'm looking for. But in this case, it's fine. Next thing we're going to do is confirm the settings. Click Finish. And now this new Hyper-V host is added into our environment. And so it's really as easy as that. You know, you communicate with the brand new server, click a few buttons, provide some unique information, and we now have this server added to my environment and managed by System Center Virtual Machine Manager.
Cool. So that gives us a view of how we would do that from a VMM perspective. So we would effectively be provisioning Hyper-V onto that blank server from nothing. It would take a few minutes to deploy. It would store that image down on the machine in a virtual hard disk, actually boot from VHD, and then we bring it into management, and we could cluster it very, very easily as well through click and drag. What we looked at in some of the elements in my demo that I want to drill into in a bit more detail, actually. So I'm going to go into my demo environment here. And my demo environment's got a living, breathing system here. So I'm inside Virtual Machine Manager as well. It'll look slightly different assignments. We've all got our own systems. None of them running on a 320 logical proc 4 terabyte host, unfortunately.
I wish.
Yeah, I wish as well. That would be nice. But as you can see, I mentioned some of the monitoring capabilities before. So we do get a little bit of information about what's going on inside the infrastructure through VMM, not as granular as what you get in Ops Manager. But one of the questions that somebody was asking earlier on around DRS and distributed power management in VMware, where do I do that? How does it work? Well, in this environment, whilst I've not got a cluster, I can still show you what it would be like to configure it. So if I go to properties of this host group, and I go to this something called dynamic optimization. That's the key, DO, dynamic optimization. And I can tune, I can make this more aggressive, less aggressive, up, down.
So what does aggressiveness mean?
It means how likely, no, it means raising fists. It means how often and how aggressive are you going to be in terms of analysing the environment and move workloads around, even if there is only a small chance of gaining a performance improvement.
So it's like how equivalent do you want to make each host, right? So the more aggressive, the more balanced it will be across the different hosts. To an extent,
yeah. The aggressiveness is, like it says here, it's going to result in more live migrations, because even if there's a slight tweak within two hosts, so one's suddenly a little bit more overloaded than the other, and it might only vary slightly, if it's set to aggressiveness is high, DO is going to pick that up and it's going to move the VMs around. If you set that to low, then it's only going to move VMs around if there's substantial gain, so you're not going to see as many migrations. So you would tune that and use that accordingly depending on your environment. And you can tune the frequency as well to check and balance at 1 minute intervals, 5 minute intervals, whatever it may be. I don't think that you can go you can go to 1. There you go. Mine's not going to, because it's not a clustered environment anyway. But I can also say, okay, what kind of thresholds am I looking for? So I can, again, tune it a bit more, CPU, memory, disk I/O. So if it's less or more than a certain amount, we can say, okay, there's less than 30% CPU remaining, then, yeah, you may want to do something, for instance. Or if you're using more than 30% CPU on a host, we should start to consider moving stuff around. So you can tweak and tune it quite granularly here. But off the back of DO, I can start to look at power optimization.
Ooh, tell us about power optimization.
Hold your horses, I'm going to. There we go, I just had to enable this box to enable this box. Because if you don't have DO turned on, you can't turn PO on. So power optimization really needs dynamic optimization as that base. So ticking that box turns it on. But enable power optimization, if I look in the settings here, I get a very nice calendar And basically what power optimization, as the word suggests at the top here, will try to evacuate hosts of a balanced cluster and turn those hosts off to save power. It will ideally need the baseboard management controller that Symon talked about before to wake up the hosts again, to move VMs back to them after they've been shut down for a period of time. So here we can trigger or tweak the thresholds of what we should deem kind of a level before we start considering whether we should consider that host for power optimizations. So if they fall below the following thresholds here, and we can define them. And we can also say, okay, I don't want any power optimization to occur between, I don't know, 9 a.m. and 5, between, it's like Minesweeper. Between
you mustn't be very good then.
Well, yeah, story of my life. I'm going to do this Friday. Oh, yeah, look at this. I could have done a face or something. I could have done something more imaginative. But there you say. So between Monday to Friday, 9 till 5, no power optimizations. But the rest of the time, power optimization is running, and hosts are shut down and restarted as needed. But if you shut hosts down at midnight on Tuesday, for instance, and at 1 o'clock things suddenly go nuts and all your servers start needing more resource, the VMs that is, and that's putting pressure on the remaining hosts, VMM will fire them back up. It won't wait until 9 in the morning to bring them back to life. So that's DO, and that's power optimization.
Now, one of the questions, actually 2 questions I get asked a lot. So first with the power optimization, is it cluster aware, right? We're shutting down certain hosts. We always want to make sure that we maintain a cluster concept of what we call quorum, which means there's enough active members participating in the cluster. And yes, power optimization, fully cluster aware, you're never going to shut down too many nodes and lose your cluster. Now, the second question I get asked a lot is, in our older version of Virtual Machine Manager, 2008 R2, we had a feature called Performance and Resource Optimization. And that essentially did the same thing. It was kind of load balancing resources when you hit particular thresholds. So kind of the key difference with Performance and Resource Optimization and what we have in 2012 with Dynamic Optimization is that we have removed the dependency on having System Center Operations Manager. In the old version, you actually had to deploy Operations Manager, and that would do the monitoring of the storage, the network, the CPU. And then Operations Manager would go send an alert to Virtual Machine Manager and tell it to do a live migration. Since Virtual Machine Manager was so popular, we decided to build this functionality directly in VMM. So you have dynamic optimization with all of this load balancing with no dependency on any other System Center component.
Yeah, but Pro still does exist, and it's important to state that. So we've got it in our demo environment here. At least I can show you the interface. So Pro, you can still connect Ops Manager and VMM if you want impact on VMs and movement of VMs based on perhaps different things that aren't related
metrics,
to. So,
right.
For instance, you might have a management pack in Ops Manager that's monitoring your hardware, and that might detect that one of the power supplies in your server has been pulled. There might still be a power supply in the server, so it's redundant, but you're now down to 1 from 2. The management pack in Ops Manager could detect that. That's a potential problem. We're now running on a single power supply, and it could pipe across a pro tip that would say, single power supply and host 159, we recommend you migrate virtual machines off that host, and you would click implement and it would do that. So Pro is still very valid and very a key part of that, and it provides that knowledge from beyond just VM specific stuff, but it always relates it back to the impact it could have on virtual machines.
Great point, great point.
So yeah, the DO is going to allow you to do the DRS type stuff. Pro is going to give you a bit more extensibility and some other options as well.
Now, I had a good question come in here. So let's say that we have power optimization enabled. We have host shut down. What happens during patching cycles? What's going to happen to that host? Will it automatically come online? Okay, sounds like someone stumped us. We will be right back to you. I will go find out the answer now.
Good question.
Respond to you soon. Great question.
Yeah, it is a good question.
We'll figure that one out soon.
Yeah, I'll have to get the VMM encyclopedia out on that one and check. But yeah, we can definitely get back to you on that one because that's useful to know, certainly from my perspective. I want to just drill into a bit more on the template side of things. Symon did a quick look around some of the template things earlier, and templates are stored in our library with VHD, VHDX files, ISO files, PowerShell scripts, and so on. I want to look at this particular template here. It's just a regular Windows Server 2012 template. And Symon also talked about some of the profiles. Just so we were clear about the relationship between templates and profiles. A template typically consists of multiple profiles. So for instance, the hardware profile here. So I could configure some hardware for this particular template here and save it as a new hardware profile. So you see that a template is actually made up of lots of building blocks, profiles, virtual hard disks, and so on. What's interesting, and this is slightly different from the VMware world, is how Microsoft uses templates in relation to virtual disks. So in the Microsoft world, I can have a VHD or VHDX file that's, for instance, a sysprepped Windows Server 2012 image. But I can create multiple templates that are pointing to that gold disk. So each of those templates might have different characteristics from a VM hardware perspective. It may have different OS, guest OS characteristics. So when Symon talked about roles before, this particular template might be for a web server, in which case I would turn on some of the web server features and functionality. But the next template might focus on terminal, remote desktop server, what was terminal services, again with different roles and features enabled. What I'm trying to get across here is I can have multiple templates, each sharing the same gold virtual disk in the first place, because it's the template deployment process that activates those kind of roles and features as part of the deployment process. But some of the other bits that I think it's worth pulling out inside the template, I can still use unattended files. We'll join to the domain as part of the process, so that's all kind of handled for you, and we can change the IP address, the identity information, and so on. But where we get very granular is starting to add application configuration options within the VM. So not just about deploying the OS, it's also about deploying applications within that OS. So I can choose to add application profiles, and I can add things like web applications in the form of MS Deploy packages. So those who are familiar with deploying web servers will know MS Deploy packages can certainly speed up how we can deploy and configure web servers. I can add scripts. I can add virtual application. It's like, wait, you're blowing my mind here. You're talking about virtual machines, deploying VMs, and now you're talking about virtual apps. What's going on? A virtual app, if you've ever heard of application virtualization, AppV as it's sometimes abbreviated down to, AppV in the desktop world is a tool that we would use to deploy a PDF reader or Office or another application to the desktop. And it's streamed across the network, cached on the local device, and it runs there, but it's not installed. Similar kind of thing with the virtual applications inside VMM. We're virtualizing server applications inside server guest operating systems running virtualized. So it enables us and gives us a new angle on how we can deploy apps within virtual machines. And we'll touch on this in a bit more detail later on. Also, SQL Server DAC packages as well are another consideration. If I choose to skip that actually and look at SQL Server specifically, so this is a slightly different section, but this would be really useful if I was creating multiple SQL VMs. So I can add a SQL Server deployment here. So let's say, for instance, this is going to be a Windows Server 2012 VM with SQL 2012 SP1. So what I do here is I'd configure my instance, ID, product key, more configuration here in terms of where the media is located for SQL. So maybe I'm going to point it at a network share. The admins I want to enable, what type of security, password for the SA administrator if you choose that. If I've already got a sysprep, a config file that would effectively provide and feed in all of the SQL-related configuration information as part of an automated SQL install, I could add that here as well, and configure some of the SQL Server run-as accounts and reporting services and so on. So I can integrate this into my VM deployment and save that as a template. So going forward, I could be deploying SQL Server VMs very, very quickly, VMs that have got certain applications and services within as well. But that's just a standard VM template. That's not a service template, a VM template here. If I look at service templates, that's where things go radically different. Because service templates use regular VM templates as building blocks and allow you to combine them into something that's more complete and more integrated. If you're deploying VM templates, I could just be deploying one VM at a time to do a particular function. If I'm deploying these are almost like Expense Manager was. It was a service, it was an application in itself. So let's look at Blog Engine here. This is a sample application we've got in our environment, and I want to open in fact, let's look at the properties of this service template first. So it's a it's a machine that's going to effectively a multi-tiered application. There's not too many dependencies apart from the web tier and some of the library elements that are in there. So some virtual disks, some zip files, web application packages, and so on. And who can see that? Who can use that template? Well, there's a selection of users here. So this is really useful, and this will come into play a bit more later on. But I want to take this into the designer, because I want to show you how you get to this kind of thing. And the service template designer is drag and drop construction of a multi-tiered application. In this case, it's probably a bad example, actually, because it's only got one tier, which is a bit of a shame. So let me come out of there, and let's look at Stock Trader, because I know that's got more. So let's open designer again. So that's what a one-tiered service template would look like. Let's look at a multi-tiered service template. So here it brings it up. There we go. Let's fit to window. There we go. So what you see here, Stock Trader as the service template. It's made up of one particular tier that's got an app v. Let me zoom in a bit to make it a little bit easier for people to see. So Stock Trader, there's a SQL tier that's got a couple of databases in there that will be configured, the DAC packages, order processing servers, and so on. These are all SQL-related databases that we want to configure. SQL 2012 is some media, an OS configuration, a processor configuration as well for the actual virtual machine. So multiple layers there that are configured as part of that tier. This particular tier over here has got a virtualized app. It's got the OS information and the virtual machine hardware information. And over here, we've got some web packages. So this will be the web front end again. And we've got some another tier that's going to provide some additional application-related functionality.
Now, you mentioned a virtualized application here. Microsoft has a technology called AppV. I've kind of seen a few questions, kind of feeling that out. Can you just kind of clarify what exactly is AppV?
Yeah, so AppV on the desktop side is a tool that we could use to package an application. So if anybody's ever installed an app at scale, you'll know typically you would deploy an MSI, silently maybe, and it would install and lay down some it may change the registry, it's going to lay down some files and some stuff on that machine. So there's going to be a bond between the app and the OS. What AppV aims to do is, instead of you installing the app on the target laptop or desktop or whatever it may be, you sequence the application and it almost puts it all in a bubble. And within that bubble you've got information about the application, a virtual registry, you've got virtual files and stuff to do with that application. So it can effectively exist in this bubble, and you push this bubble over the network and stream it to the end user's desktop or laptop. And it looks like the application is running locally, it's in the start menu, there's an icon on the desktop. It looks and feels like a regular application, but it's not installed, so you won't see it in add remove programs, which means updating the application and cleaning it and keeping that OS nice and clean is inherently more efficient. So it's a streaming of application technology. The key similarity between AppV on the server side, which is exclusive to VMM, and AppV on the desktop is that isolation, that bubbling. You know, we're placing the application in a bubble and we're delivering it as part of this service template. So it's not actually good. This particular BSL deployment here, this business service application that I'm pointing at on the screen, that's not going to be installed in this guest OS, which gives us flexibility around when we need to perhaps manage the image. Maybe we need to apply an update to the host. We can radically and rapidly shift these virtual applications between OS instances very, very quickly, whilst retaining a high level of availability for the workload. And all of these tiers are connected to virtual network adapters and connected to, in this case, CorpNet. I just want to select this one here and look at some of the properties of this. So this is one of the tiers in particular. When this comes up, there we go. So I can say for this particular tier, do I want to stop this tier being migrated automatically around the infrastructure? Which order will this particular tier of the service be deployed in? So maybe you need to lay down the SQL Server first and then the application tier and whatever. Can this be scaled out? So when we saw the demo, the art of the possible demo earlier on, we scaled out through automation an additional front-end web server, for instance, to handle the increased load. So this is me saying, can it be scaled out? What does it start at? What's the maximum? What's the minimum? You can have none, which might not be such a good thing. And these upgrade domains are useful in terms of orchestrating the order in which things are updated when you choose to patch and update a service template. So we can orchestrate, if you want to update the whole service from version 2 to version 3, the order in which the tiers of this service are updated and how we keep things online as optimally as possible. And this availability set is similar to what Symon talked about before when we keep those VMs apart from certain physical hosts. And that's where we would enable that in VMM for this service. I can also enable it and create availability sets separately as well. So in this service template, we have all the hardware config for this particular tier OS. It's similar to what we've seen before. So you'll see a bit more of a more populated application config here. So a web application with pre-install, some script, post-install, some SQL configuration, not particularly in this tier, some settings and so on. So that is a service template, very, very granular. But add to this, I can add load balancers. So if I'm using F5 or Netscaler or the Microsoft load balancer, the Windows server-based load balancer, I can add those in here. I can add more of my baseline templates. So let me fit this to window. Here we go. So if I wanted to add this particular template, I'm just clicking, I'm dragging, it's over here, and now that's connected in automatically, and I would start to customize accordingly, and all of a sudden I've got a 5-tier service template. I don't want to go too far out of control, so I'm going to close that down. But from there, once I've saved that template, it enables me so much power in deploying multi-tiered applications, and it's native to VMM, which I think is really, really, really useful and powerful. Now, we'll talk a bit more about maintenance later on, so I'll come back to the baselines and stuff, but hopefully that's given you an idea of service templates and what they're used for, why they're really useful. And you may use regular templates and you may use service templates just to deploy a collection of Windows servers with a couple of roles enabled, rather than focusing on the application layers and so on. But it's certainly very powerful if you do choose to use it. So what we've seen is we've looked at standard templates, we've looked at roles and features and the application layers, and we also explored templates 2.0, I like to call them, so service templates, really evolving how we move forward with those. And to wrap up, it's helping us standardize. It's helping us scale out our web application and data tier. We talked about hardware profiles, guest OS profiles, and the application profile within each of these tiers. So it enables us to deliver these standardized services very efficiently and quickly. And we can deliver them across our standardized fabric. So we've got that centralized, that pooled set of compute, and we're deploying them into our clouds that are aggregating a lot of that compute and storage and networking. But what makes it up, we've looked at some of this specifically already. The hardware profile inside this particular template connects to a virtual disk. The OS profile is specific settings around OS, domain join, unattend files. When we're talking about the web tier specifically, application profiles like MS deploy packages to speed up how we deploy web servers, and a configuration file as well that's associated with that. The application tiers, similar kind of thing, assigned to a virtual disk. It may share the same VHD or VHDX file, like we said before. One template can share, multiple templates, sorry, can share individual virtual disks. And when it turns SQL, we've got the SQL profile, configuration files, SQL DAC as well. So there's lots going on there to embrace if you're seeing it for the first time, but all of this is stored in the service template library. So we store it there, you can create new versions of these services, and we'll talk on that when we talk about patching later on. But we think about SQL, we've kind of gone through this already. It's helping us to deliver consistent config, names in instances. We saw we could include product key. We saw we could point it at a certain media source on the network. We're effectively constructing this on-demand delivery of SQL. Think about a test and dev team that need more and more SQL databases to test certain applications. You could just have a standardized SQL template that includes it all built in. So they're not having to hunt around for the specific product key or a certain network config, and you can pre-configure all of the relevant settings around user roles and service accounts and so on. It's connecting through the DAC packages, defining the instances, the migration behavior, and also the service accounts, like we said, to define. So all of that SQL goodness you can define in the profiles and attach them to a VM. And that way you're really delivering a very complete and streamlined way of delivering SQL Server specifically into the environment. And we touched on App V. You sequence, you package the application. Sequencing is the term given to bubbling the application, if you will. So you're packaging it in an environment, so you might use a virtual machine, you might use a physical server, you're probably going to use a VM, but you're sequencing, you're packaging the application into this bubble. It's consistent, so once you've packaged it, it stayed the same. So people aren't going to be able to fiddle and tweak with this application, it's standardized, and you deploy it as part of the application profile within the service template. And it's easy to update these AppV applications. You can crack these open, these back in the sequencer, apply the relevant updates or package updates, whatever they may be, and deploy them as new service templates through self-service management. And that's the powerful thing. Because the server AppV applications, they're intelligent around things like state as well. So we can collect state, we can ensure that if we want to upgrade the underlying operating system without losing the deployed application state, the AppV application can be lifted up along with the state of the app, the current state. We can swap it onto a different operating system that's perhaps had a service pack applied, or it's had a couple of patches applied, and drop it back down and go from there. So it's extremely flexible. Instead of countless reboots and reinstalling an application from scratch, Server AppV gives us a new angle in how we manage that. But it's only Windows Server host. I can't deploy Server AppV to Linux. And it's not every application. So web applications can be virtualized, accounts that need to be included, DCOM binaries, WMI providers, even SQL Server reporting services can be virtualized. But we can't virtualize things like drivers. So if your application installs a driver, that's going to be a no-go for Server AppV. That's not to say it couldn't be deployed as part of a service template. You would just have to do a little bit more work around manual configuration and perhaps a little bit of application scripting at the application level layer within the profiles. But you could certainly do it. Registry settings, COM, Java stuff, .NET. We've kind of covered all of this already, and I don't want to go into too much more depth in Server AppV. But lots of information about how you can sequence your apps on TechNet as well, so it's certainly very valuable. It's powerful, but I'd recommend learning more about it as well. We looked at the Service Designer, using the ribbon, contextual, wherever you are, kind of like using Office, nowadays, 2007, 2010, 2013. You click somewhere, everything's context sensitive. And you saw how easy it was for me to drag on a new template from my library and add it to my service template. Really easy, in the same way I can add networks and load balancers. And I can set properties such as cost center, release version. I can scale it out and so on. And it's really, really straightforward. I can preview what it's looked like. I didn't go through this in the demonstration. So I can preview what it's going to look like once it gets deployed. Because what you might have in your service template is a set of generic configurations that when you deploy, certain naming conventions may be applied. So SQL 0002. mid 002, 002, 003 here. They're what this next deployment of that particular service template will look like. Okay, so that's pretty useful. Settings allow you to deploy variables, specific variables, and we've got that ribbon bar. And once it's deployed, we can look at what's going on at the service level, the tier level, the VM level. So we're seeing everything about that particular service template once it's been deployed. And the great thing is that it's not just about VMM. It's not just about Virtual Machine Manager deploying the particular template. That's one part of it. Once it's been deployed, Ops Manager sees it as a distributed application, so we see the whole picture. Service Manager sees it as a business service, so it understands how these things are all connected. We can monitor it on the whole, and we can view it at all of the different levels as well. So that's the key thing with service templates, extremely powerful. Now, Simon talked and showed a little bit more about clouds before, and clouds really enable us to combine and aggregate our infrastructure into pools. So we saw how Simon used a cloud before, and there was virtual machines and so on inside those clouds. But we can have clouds across our data centers. Simon used the example of geographically separated as well. But we're able to group and aggregate all of the storage network and servers within a particular infrastructure into a cloud. And that way we can then present these private clouds through to our different business units. So to hop over very quickly to my demo environment here, I'll go through a very quick cloud creation. Here we go, create cloud. What's the name? Simon CX Cloud. We'll change it to cloud. There we go, Simon Cloud. I'm not going to give it a description. What hosts do we want to use? Well, I'm just going to use all my hosts in my host group. Logical networks, what networks is going to be available to this cloud? Are we going to use any load balancers? No. This is only me saying, are they going to be available to use? It's not me saying they are exclusively used as soon as you click this box. VIP templates, virtual IP templates are associated with load balancers, so we're not going to choose those. Port classifications allow me to classify virtual machine network adapters that are going to be inside this particular cloud. So I might want to enable high bandwidth, low bandwidth, and medium bandwidth, which means when I deploy VMs into this cloud, I could use the QoS services that I talked about earlier in the day to actually apply to some of the VMs in this cloud. But I'm going to untick those because that's not necessary for now. Have I got any storage associated with this cloud? Well, not in this case. Any library? Do I want to allow people to store stuff that they want to move out of this cloud? Well, not right now. Capacity. Do I want to put certain limits on what they can do? So in this case, actually, I'm going to say this cloud has a maximum of 4 virtual processors, 12 gigabytes of RAM, let's see, 50 gigabytes of storage. Quota points are an alternative way of me specifying what I've got access to, what I can deploy into the cloud. So I might give a service template 5 points, and if I've got a quota points for the cloud of 10, I can only deploy two services from that template into the cloud. And finally, how many VMs can I run? Well, I'm going to say 4. Capability profiles, Simon highlighted these before. So is this cloud going to be able to support VMware hosts, Zen server hosts, Hyper-V hosts, just Hyper-V in this case, and finish. So we created a cloud. There we go, create a new cloud, job completed, Simon Cloud. So now if I go back to my clouds, there's Simon Cloud, and I can assign that to somebody. So who's going to own this particular cloud? Well, I'm going to assign it to the MVA team that I've created specifically for this environment, of which Simon is a member. So the MVA team have now been assigned the cloud. There it is. The quotas for the cloud we've already kind of defined already. The members, yep, Simon, name and description, and so on. So this is us doing a bit of delegation and role-based access of this particular cloud, and we can see which service templates we're allowed to use within this cloud as well. So that was a very quick kind of how to create a cloud, but I've ultimately just given you, as an application owner, a chunk of my infrastructure that's of a certain size, and you can access and do what you want to a certain extent with that. So as I said, we logically group into clouds, create clouds, and create tenants. We'll look at tenants a bit later on, and VM networks as we look at service providers as well. Networks is pretty straightforward from the context of we need to allow our cloud to communicate, so I can create those as well. We can view those deployed services and VMs, like we've already talked about, but I can over-provision clouds. I can over-provision the resources. So even though I may only have 2 hosts in my infrastructure, you saw in the last demonstration, I had a lot of clouds listed there. But if one cloud consumes all of their allocated resources, that's probably going to impact some of the other clouds. So I probably don't want to get into that situation too often. I'm connecting my physical infrastructure as we saw. We aggregated all of that, chose the networks that were appropriate, types of storage if we did have any classified storage attached. And I was able to set limits around what the capacity of that particular cloud was. So I can adjust those as necessary, so I can go back into the properties and change it, but for my argument's sake, it's very, very easy. And you saw me control the types of VMs that people can run in this cloud. So it's going to be Hyper-V VMs, it's going to be VMs of type Gold or ESX server capability VMs, whatever it may be. And I attach those to controller usage. And the final area that I really want to quickly demonstrate is how we start to access that information in a role-based way. You saw me delegate that cloud to Simon very easily, very simple. I delegated that to him from a perspective of he can now access that cloud, but how does he consume it? How does he access that cloud infrastructure? Well, if I pop back to the demo very quickly and I go over to my app controller infrastructure, an app controller, remember that self-service portal we saw briefly before, I'm going to log in as Simon. I set your password so I know what it is. I hope. I'll log in and all I should see, one virtual machine manager cloud. I've no access to any Azure subscriptions. They've not been configured. No access to any service provider clouds. I've just got the one cloud. There it is, Simon Cloud that we created before. Now, I've not given Simon any specific limits, so I've given him pretty much free rein. So if I'd have turned on his specific caps for his user role, he would see the limits that I've got in place for this particular cloud. But I'm going to go deploy, and you'll see all I can deploy into that cloud. If I select a template, now I'm logged in as Simon, all I can choose is Blog Engine and the template that I've made available to him. I can't see all of my other templates that I've got available, Stock Trader, the other version of Blog Engine. I'm really restricting him through role-based administration and control consumption of what he can access and what he can use. So that's a pretty simple way of enabling him to use the relevant resources that are available. And VMM has a whole host of different administrative roles. So the read-only administrator can do pretty much a relatively small amount of stuff. So a help desk user would be a good example here. They can log into VMM, but they can only see host groups and clouds, but they can't really do a lot. So it's useful for visibility. The self-service user, they can only interact with clouds. They can't configure hosts and tweak things like that. They can author templates, deploy VMs and services. So this is aimed at like the expense manager example person we talked about before, who's got a vested interest in deploying an application. We can observe a quota. We saw that briefly before as well. We go one step further and we've got a tenant admin. And the tenant admin we'll talk a bit more about later on when we talk about service providers. But this is certainly when you're thinking about hosting multiple infrastructures, you may have an administrator that's focused specifically on a certain set of clouds. So a tenant administrator will use VMM in that way, configuring networks, assigning clouds, managing clouds. But he's not going to be concerned with some of the underlying infrastructure. Kind of second in command, we have the delegated administrator, who can do a little bit more around the fabric. They can control hosts and host groups, networking and storage. They can create clouds on the fabric and assign those clouds to different people. And then you've got the administrator, where any other specific task within VMM, this person can do everything. That is the kind of head person within the VMM. And you can have multiple people assigned to each of these roles.
So just to kind of break down the distinction between a delegated admin and a full admin a little further, think of the delegated admin as essentially someone that could have all the permissions, but they've been scoped down. So to a specific cloud, a specific set of actions. Maybe, for example, they can start and stop VMs, but they can't actually create a new VM. So they have the potential for full access, but we kind of carve it out in a specific area.
Yeah, so to use your example before when you talked about geographies, you might have a delegated administrator for the US. You might have a delegated admin for Europe and one for Asia, and you might be part of the admins group that can do everything across everywhere. So that's perhaps one way of looking at it.
Great example, yep.
And we can assign actions, as Simon said, to the different user roles. So we can create custom roles using those originals as a starting point. So I can say, okay, the self-service user role for an application owner looks like this, but I'd like to tweak it in such a way. So I can change and give them remote connectivity, local admin rights, the ability to author a VM network. So I can transform them as needed. But it all integrates with AD. So if I want to add a new user, in this case to the sales admins group within VMM, it's all based on AD. So I can hook up and give Simon, who might be a sales guy, I can give him access to this particular role, and then he'll be able to log in through App Controller and get access to the clouds that have been delegated to sales admins in this case. But it is that controlled empowerment as well. What you saw earlier in one of in the Art of the Possible demonstration was how I can start to deliver a more complete infrastructure, how I can start to deliver a request-based approach to getting new services. And this here, Contoso IT, is a slightly branded, customized version of the Service Manager self-service portal, but that's providing me with service offerings that I can consume from the service catalog. So if I'm interested in signing up for training or building access or getting a VPN or something to do with cloud services, I can drill into one of those based on who I am. So I may not see all of these depending on who I'm logged in as. But what I'm doing is presenting to the end user the ability to interact and engage with IT through a standardized set of services, and enables that consumer, me in this case as the application owner, to choose what I'm after and ask and request through a change managed system, resources, a new printer, a new laptop, whatever it may be. So it's consistency, it's standardized, and it's streamlined, it's intuitive. And these service offerings, as I detailed before, it might be, think of it like here's the restaurant menu, there's the service offering. What you've got underneath is lots of dishes you could choose. So here's the private cloud menu, but what's under private cloud from a service offering perspective is lots of individual requests. Request a cloud, request a VM, request a SQL instance, so on. And you would architect and deliver those services and service offerings and request offerings that are most appropriate to your working environment. But we do also continue with that role-based administration for this environment. So if Symon logs in, he may see private cloud offerings, enterprise line of business app offerings in the portal that he can ask for, request, and whatever it may be. And I might log in, and I may only see VDI offerings. Do you need a new virtual desktop? Yes, please. OK. We'll submit that request, and automation will kick in and deliver that to you within the next 30 minutes, or whatever it may be. If I'm a dev team, I may only see dev offerings. Do you need a new set of servers to do some dev work with Visual Studio installed and SQL Server? Yes, I would like 2 of those instances. Next, submit. The ticket gets raised. Once approved, that developer gets access to their new development offering. Lots of ways of slicing and dicing, but it's all based on who the user is and mapping that to Active Directory. And identity and that whole AD side of things is very core and critical to the Microsoft offering. And that portal is very simple. It's customized. It's running on SharePoint 2010 or higher, just a foundation edition. So it doesn't necessarily need some of the more advanced versions of SharePoint, more of the enterprise version. It can run on SharePoint Foundation. It's customizable, so if you've got SharePoint skills, go to town. Really have a go and see what you can build and customize in the way that's most appropriate to your environment. But how can we help you get started? Well, the Cloud Services Process Management Pack, which is the pack is just slightly obscured there on the slide. The CSP, the Cloud Services Process Pack, or Management Pack to give it its full name, gives you a bit of a leg up when it comes to delivering the service requests and request offerings for private cloud. Okay, so you think about what we're delivering, what we saw in some of the demos earlier on. I requested private cloud of a certain size, of a certain recovery objective, and so on. Well, with the Cloud Services Process Pack, when you import it into Service Manager and integrate it with some of the other System Center components, it's pre-built request templates and service catalog content. So enabling me to radically speed up defining and delivering a much richer private cloud-focused service catalog and interface for you to engage with. So asking for VMs, projects, registering tenants, requesting services, and so on. So basically think of it as a jump start to achieve a faster time to market in terms of delivering a more rich self-service portal. And it's included and integrates with SP1. So what have we talked about? We've talked about advantage in standardized templates, how we can deliver quota and manage that whole process, empowering those application owners, creating, managing clouds, allowing them to move, as well as moving workloads around. We allow them to move resources between repositories. So Symon gave the example of different geographies and having libraries per geography. We can replicate and manage that whole process to ensure that when you're deploying from your European infrastructure, you're not using templates that are solely based in the US, because that would take a long time. And there's a single management point. So System Center is giving that single management point for looking at your infrastructure that's on-premise, managed by VMM, and also applications and services that are running in Windows Azure as well. So how does VMware compare? And I guess this is probably a good point to start thinking about just what VMware are doing in this space. Because with their recent acquisition of some of the management tools they've got in this space, some of the tools that they've been building as well, they share some of the similarities with Microsoft, but there's some subtle differences. So when we think about the requesting of private cloud resources, that vCloud Automation Center I talked about earlier on does provide the ability to request private cloud resources, but it's not tied in necessarily to any true CMDB. So it's not integrated with a true service management solution. So it's lacking in some of that area. When we think about templates, whilst we can both deploy from templates, standardized templates, each VMware template has a VMDK. So what you can find is that the templates start to, as you have more and more templates, you can have more and more VMDKs. But as I said before, our capability within VMM to have a gold image with multiple templates attached is very, very useful. We deliver that roles and features granularity for configuring the template. And that application layer is something that VMware can deliver with their new vFabric application director technologies to deliver multi-tiered and more granular delivery of applications within VMs. But we don't have a server app V type technology to stream applications within those virtual machines. So it's a little bit more static and a little bit more challenging to update and maintain. And what's interesting on the application front is that what we're building into VMM is not only the ability to deploy these service templates with applications as part of their core, but it's also about the updating and maintenance of those service templates as well. Whereas with VMware, with vFabric Application Director, there's one version that's used for provisioning, but there's a different version that you would need to buy for release management, so updating and maintaining those provisioned applications. So it's something to consider. It's all in the box with VMM for the multi-tier templates, the service templates, and deployment across heterogeneous clouds. So we can deploy those service templates onto Hyper-V, VMware, and Citrix-based infrastructures. Whereas VMware, now through its vCloud Automation Center, can deploy onto non-VMware infrastructure, but if it's going to deploy onto physical infrastructure, then you're going to start to accrue different licensing costs outside of the vCloud suite. So that was a bit about delivery and infrastructure and management. Now we're going to look at monitoring. And with monitoring, we're thinking about how we can better gauge a view into our infrastructure and understand just what's going on with the applications. So we've got this element of maintenance. How can we maintain our applications? How can we keep them updated and efficient? Well, the template process we've talked about before, in-place upgrades, so changing applications and template settings without replacing the OS image, changing memory, updating application packages, and maintaining all of those changes is part of the service template process. So if I've got a tiered service template and I want to update a certain tier, I can take all of that into account, all of the memory changes, all of the CPU changes I need to make, and factor that in terms of updating that whole service template with keeping the application up and running as long as possible. And I can also deliver image-based updates as well. So using things like Server App V, I can lift up the application, replace the operating system with a new OS image. I've captured the state along with that application, and I can put it back down on the new virtual image as appropriate. So in-place updates we've talked about. I can go from version 1 of a service template, which has been deployed. I can copy it using the service template interface within Virtual Machine Manager and name that one version 1.5. Make my necessary changes to the service template. So I might need to increase the RAM of the web tier. I might need to increase the disk capacity of the data tier, whatever it may be. I can publish that template over the top of the old one. The notification will go out that there's a pending service update, and VMM will orchestrate the rest. So VMM will orchestrate updating the different tiers as part of that, keeping things up and running as much as possible, maintaining availability through those use of those upgrade domains that I talked about earlier. So maybe if you've got a web tier that's consisting of 3 VMs, it's not going to update all of them simultaneously. It's going to do it in a staggered way. So it's going to take all of that into account. And the same with image-based updates. We deploy a template from the library. We update the template from a copy, change the version number, update the virtual application or whatever it may be, and change the disk perhaps to Windows Server 2012 RTM to Windows Server 2012 with lots of updates installed, whatever it may be. Publish that, and similar kind of thing happens. VMM orchestrates the whole process of all of the tiers underneath. So it might be that we use the upgrade domains again to upgrade one particular VM within the app tier before moving on to the next one to ensure that we're always trying to maintain application availability. We can also keep our private cloud infrastructure up to date. So we can keep and ensure that our components are up to date as well. So let me look at my particular infrastructure again. Let me close App Controller. And let's see here in VMM, because there was some questions around patching. Do I use cluster-aware updating, or would I use VMM? Well, VMM has a very similar capability here. So I can define within VMM, because remember what Simon showed us before, I can connect VMM to an update server. In this case, I've connected it to WSUS. It could be a downstream WSUS server that's pulling from an update WSUS central source, whatever it may be. I could connect it into Config Manager, and that's all documented on TechNet as well. But in the library, I can define these baselines. And there's 2 that come out of the box that are just samples, but you can use them and evolve them, or I can create a new baseline. And basically, I'm saying, okay, which updates do I want to include that have been published? So I can do a search, I can browse through all of the list of updates. So I might want to say, okay, this particular update, add those to my baselines. This is an ongoing maintenance type situation that you're going to perform. What's this going to be assigned to? Well, this is just going to be focused on my hosts, or it could just be anything connected with VMM. This isn't going to patch VMs. This isn't going to keep virtual machine guest OSs up to date. That's still something you're going to have to factor into your overall patching infrastructure. But I could just choose all hosts, I could go next and finish, and what that's going to do then is assign that particular baseline to those hosts. And when I come to my fabric again, and I go to my compliancy view, and I'll click on all servers, you'll see that a number of my servers, let's just select the WSUS server for argument's sake. We'll scan it. It's going to scan and check against the baseline that we've attached to that particular server, and it's going to deem it non-compliant. And I'm going to get the remediate option, and it's going to say, okay, you need these 3 updates. And it's going to, if this is a cluster, so if these were some hosts, allow remediation of clusters. It's going to put things in maintenance mode. It's going to move virtual machines around. It's going to orchestrate the whole process of keeping those key VMM components up to date. That's pretty powerful stuff. So define the baseline. What updates do you want to ensure you're applying, pulling from that central source, scan stuff, and then remediate. So orchestrate the whole process of bringing servers up to compliance by installing those missing updates. And all of that progress can be tracked within VMM. And here's, again, a bit more of an explanation. We enable it. We manage those baselines. We scan the infrastructure. And remember, it's just the VMM infrastructure, the component parts, the update server, the library servers. It's not going to patch the VMs. We remediate by delivering the updates down. And it's going to move stuff around. And we can also classify certain updates as being exempt. So we can say, you know what, this update doesn't apply to this host in the sense that it does apply in the sense that it's valid, but we want to exclude that update. So we can put in place exemptions for certain updates, even though they may have been valid for that particular host or server. So we want to think about the deep application insight as well. And at this point, I want to hand over to Symon, who's going to give us a bit of a look into some of the insight within the infrastructure. So have a look around how we can start to use Ops Manager to monitor some of that infrastructure and see what's going on in the environment.
All right, thank you. So we're going to switch over to this demo environment. We're basically going to go and kind of show a really nice integrated scenario of all these different System Center components. So I'm going to go ahead and I'm going to start Service Manager. I'm going to start Orchestrator, which is our automation engine, and I'm going to start System Center Operations Manager. Now, what I'm going to be doing in the background here is I'm going to go launch a website. This is the website that we're going to be monitoring. Now, you might know of Din and Now application, probably seen this one before. So let's get rid of this boring application by just crashing it here. Run it with PowerShell. So this is basically a script that simulates a workload, and when I refresh, service will be down, service is unavailable. Now, essentially, what we're trying to do here is build automatic recovery into our environment. Our goal is to provide continual service availability. Now, in some cases, that's not possible, right? Applications crash, it happens. But what we're trying to do is automatically recover it. Now, in a lot of traditional environments, when a website goes down, you might have Operations Manager monitoring it, and it might send a call to your phone, call to your pager, send an email, send an alert, and you'll have to go manually fix it. But we found out that a lot of these problems where you have service outages, it's the same problem every time. And a lot of the IT departments have a clear set of checklists that say, step 1, do this, step 2, step 3. So rather than having you manually go through these 3 steps, let's automate it. Again, this being the goal, one of the key goals of private cloud, providing this automation to free up your time. And also, you're going to have better service uptime as well because, hey, if we can automatically recover this, it means the service is going to come online quicker rather than to have to include manual intervention. Now, by now, all of our services, we should have detected this. So I'm going to go ahead and look at System Center Operations Manager.
So what you're seeing there is an alerts view, and that could be alerts from all over the infrastructure.
That is correct. So we are actually looking at, so let me go back. We are actually looking at all of the alerts, and we can see the alert here, web application, Din and Now website is unavailable. And so what this means is, yes, Operations Manager has detected it's down. is raise the alert. Now, what we're going to do here is we're going to tie this into Service Manager. And again, Service Manager is our IT department's kind of centralized ticketing system. And within Service Manager, when there's an alert, even if we fix it automatically, it's a best practice to document it, right? We want to always keep track of these alerts. Then when we start to look at weekly or monthly reports, we can see which components or which areas of our infrastructure are particularly faulty. Now, what we're going to do here is take a look at these work items, take a look at our incident management, and take a look at all open incidents. Now, I have a lot here, 550, so I'm going to go ahead, filter it by dinner, and we can find our dinner now application. So once again, our website crashed, Operations Manager detected it, created an alert. We now create a ticket in our IT department system.
Automatically.
Automatically,
yeah.
So no manual intervention. Now, of course, we did have to pre-configure this, right?
Yeah, you connected Service Manager
We connect
with
everything, and we say, hey, this alert equals this type of action.
Yeah.
Now, what we're actually doing here, this is what's known as one of our incident forms. And we say, hey, we've seen this problem before. We know exactly what we need to do to resolve it. So we can assign different priorities, assign owners. But we also have the ability to create an automatic activity associated with this. And what this is going to do, this automatic activity is basically going to go and invoke a orchestrator runbook. So we got this activity. Whenever this alert is raised, it's going to go ahead and start our runbook. So I'm going to exit out of that and move over to System Center Orchestrator. Now, System Center Orchestrator, again, automation engine. Now, again, what's happened? We have a problem, we report it, we create a ticket. Now here's the step where we automatically try to resolve it.
What are these on the screen here? What are these blocks?
Great question. Let me quickly walk you through these. So the first block we see here is get incident. So we basically connected Service Manager to Orchestrator, and when we get an incident, that initiates an activity.
And you've just dragged that on from the right-hand side.
That's correct. We have full drag and drop here using all of these different activities. These are called integration packs. They're actually conceptually similar to a System Center Operations Manager management pack, where you have individuals, companies, OEMs that could build these customizable units that have what we call activities built into them. And these activities can call PowerShell, they can call actions. And it's really important to notice this is not just Microsoft technologies. You can see I have my vSphere components in here. I have Netcool. And so you could go download these for free from a lot of our OEMs.
Yeah.
Now, first thing we're going to do as part of this workflow is we're going to test our website. Make sure it really is down, because it could be a false positive, right? We have a network glitch. So before we try any recovery actions, we want to really make sure the website's down. Now, if it turns out it's online, we could just say, mark as resolved, move on. But let's say it's not. Now, with our traditional step-by-step of troubleshooting, first step is going to be reset IIS. And so we know what we're going to do every time. Let's automate it. We'll reset IIS. Test the website again. If it's resolved, mark it as resolved, case closed. If not, we're going to try our second troubleshooting step. Now, this one's more advanced. It can impact other components in the environment. So we're going to try the easy one first. And then there's a second place. We're going to restart our application pools. Do the same thing again. Test whether the website's running. If it's fixed, we mark it as resolved. If it's not fixed, then we're going to go alert our admin and say, hey, we went through our basic troubleshooting steps in the knowledge base article. The problem still wasn't fixed. We need to get the manual user intervention. But the goal here is to save time on those initial troubleshooting steps. Have it automatically reported.
Yeah.
Have it automatically documented.
So you might be effectively circumventing Tier 1 help desk, Tier 2. You've gone through those steps. Those are the kind of things they would try. And now you would only escalate if it's absolutely
exactly.
necessary.
Consider this like an escalation.
Yeah.
Now, hopefully, I'm just going to quickly refresh everything here. Hopefully, a lot of these alerts are gone. And our dinner now application alert has gone. So we're back in the Service Manager. We've marked this ticket as resolved. The ticket's been automatically closed, so it's not going to involve the help desk people until they start to go through their monthly reports. Generally, they won't see this. So we'll go back into Operations Manager. We'll refresh again. Okay, it looks like things have changed here. So finally, we'll go back to our website, and we'll hit refresh. And hopefully, if everything's worked, we created the alert, we fixed it, we've automatically resolved it. When I click refresh, our website is back.
Lovely.
So that's a great example showing the power of these integrated systems across all the System Center components.
Yeah, and that was a great example. It involved automation, it involved originally starting from just a monitoring tool. But it's not just about the monitoring, it's also about the knowledge and what we can gain from that insight. And the thing about Ops Manager is it's extremely powerful at monitoring pretty much anything. I mean, when I was in my blogging days a while ago, seems like many moons ago, one of my final blog posts was around how somebody had written a management pack for Ops Manager to monitor a coffee pot. You know,
I have heard of that one, the coffee pot one.
They had a camera focused on the coffee pot, which was detecting pixels. And when the pixels went below dark pixels went below a certain part, an alert would fire. Now, if you think about, fast forward to 2012 SP1 with Orchestrator, you could have all sorts of automation coming off the back of that coffee pot.
You could have a robot go pour us more coffee,
have a robot,
right?
all sorts. The mind boggles, more patents opportunity there. But Ops Manager, that's the flexibility of it. That's the beauty of it, is it can be tailored to monitor pretty much anything. But the core knowledge we build into Ops Manager to help you, coffee pot, silly example aside, but it's great as a kind of example of extensibility. But just what we do in the box, management packs from the Exchange team, SharePoint, SQL, Hyper-V. Who knows Exchange better than the Exchange team? Who knows SQL better than the SQL team? Same about SharePoint, same about other Microsoft workloads, and partner workloads who build their own management packs. They give us the insight across server-side backend, client-side user experiences. So if you wanted to set up an automated test for Dinner Now, you could set up a synthetic watcher node that is always watching and testing Dinner Now as that web page, and as soon as it went down, that automation would kick in automatically. It wouldn't take a user to discover that. It would be automatically discovered, latency, or other components of that website and that client-side experience. So we can do some cool stuff both on server-side monitoring, client-side, and, as I've said, kind of synthetic testing as well, testing pass-through applications, availability, response times, and unexpected responses. So it's very, very granular in what it can deliver. And what kind of things can we see? When you touched on Ops Manager, we saw the alert view there, which was like a consolidated list of the stuff that's happening that we perhaps need to react to. There was quite a bit of red. But we can also monitor CPU, disk, memory. And these dashboards can be customized, and it's a lot more granular now what we can deliver in 2012. But we can define those SLAs and ensure that we're meeting them with SLA dashboards as well. We can trend usage over time, so we can see historical. Remember, we talked about resource metering before, capturing that information. And it allows that broad coverage with partner management packs. So we'll do our best to release management packs for all of our stuff, but if you've got Dell hardware, HP hardware, NetApp storage, IBM, EMC, F5 load balancers, whatever it may be, ask them if they've got management packs for those, because in most parts they have, which means you can import them into Ops Manager and start to monitor those components side by side with your other components as well. And that brings on to that management pack extensibility. There's loads in the catalog. Ops Manager's catalog, you can integrate right from within Ops Manager, download the latest management packs, or use the Pinpoint website to pull down more of the third-party management packs as well. Not all of them are free. Some of them do have a charge, but generally the chargeable ones are more capable and more comprehensive. A good example is the Veeam management pack that monitors a VMware infrastructure. Very, very granular, very powerful. We might have a look at it later in the heterogeneous section, but ultimately that's a chargeable additional management pack because it's providing extensive value to that customer. But it's not just about seeing that there's an alert been fired. So Simon saw that Dinner Now application, okay, something's gone wrong. If it had drilled into that and looked at the alert properties, you'll find that there's not only valuable product knowledge that we've built into the management pack, so if this has happened, this could be the cause, try these things to resolve it. So helping you, the IT pro, have that Ops Manager in your back pocket to help you diagnose and understand and remediate those problems. But if it's a specific environment or specific application you may want to, that's in your environment that's unique, you may want to add company knowledge. So I might say, you know what, this is always doing this. It's false positive, or it's something like, if this happens, we need to do this. I'll document that in the company knowledge section. So you can have specific company knowledge specific to your environment that's stored within the management packs as well. So that means for you, it's very tailored to your environment. And it's about that whole application health. So what we could have looked at in Dinner Now as a service, there's database components to it, there's virtual machine templates, there's virtual machine specifically running. And we can get a view of that entire application health down to the virtual machine, the database, the web, the Windows OS, whatever level it may be. Now, VMware offer in their portfolio something called Infrastructure Navigator, which provides a similar kind of view. It shows dependencies between applications and VMs, but it lacks some of that health and that alignment to health and application performance. And that's where Ops Manager, with its distributed application diagrams, of which you can construct your own to model your own specific applications that are bespoke in your environment. Obviously, our service templates will be accurately modeled and so on, like we talked earlier, but you can build your own. It's extremely flexible, powerful, and it's given us a great view into what we can show within the infrastructure. It's extended by networking monitoring, discovering different network items, switches, routers, other networking components. We can monitor those in a granular way now and visualize things like node view, network vicinity view, understand where virtual machines relate to individual physical network infrastructures as well. And finally, we can report on all of that. So the utilization of the networking switches, port traffic volume, packet analysis, all of this network monitoring is just in the box with System Center Ops Manager now in 2012 SP1. So we've done a lot of work there. So here you're seeing network nodes with the slowest response time, highest CPU usage, highest utilization on certain interfaces. And that's all in a rich, customizable dashboard, helping us identify those key areas of information, such as underperforming nodes or some of the detailed content and other devices that are present within the infrastructure. And like I said before, having that view of how does this physical network device relate to some of my virtual infrastructure? So there's ties between physical hosts, virtual networks, guest operating systems, and virtual machines. So helping us build that relationship so we can help our architects understand just where stuff is in relation to our actual fabric network infrastructure. And we can drill in detail and see what's going on, what particular port number, model number, where that's located, if we've filled in that information, who the vendor is in this case, display name, and so on. So lots of granularity across not just applications, but also networks and storage. So thin provisioning alerts, dashboards to show usage from storage spaces. Storage vendors can plug in as well. Map VMs to discovery of certain storage repositories on the array. So as you can see, as you can probably gather, we're aggregating lots of useful monitoring knowledge and aggregating it together into one view within Ops Manager. But it's also about using that information wisely and helping our development team fix problems. So go back to Simon's dinner now example. What if we'd had an issue with a certain application that needed fixing? So let me just jump across to a quick demonstration here in this environment where we'll look at Expense Manager again. And regular virtual machine related monitoring tools will be able to tell us that, okay, Expense Manager is up and running, everything's running fine. But when we look in and drill in and monitor this at the Ops Manager level, where we can look inside the application and understand what's going on with Expense Manager as an application, we can see that response times are not particularly good. This is a bad situation to be in. We could have had an alert that says, yep, the transactions, the response time is too high. We're not delivering a good level of service to the application users. What can we do about that? Well, in the Expense Manager view, we've deployed the application at RTM. It's fine. It was deployed as part of that demo earlier on. And if I refresh the page, we'll see it's hanging a little bit. Still not doing a lot. Oh, it's back. Not great performance. So let's drill into the diagnostics of this, and we can see that within Ops Manager we're looking at the application diagnostics. This is a custom Expense Manager .NET based application, and you'll see the average time for the web services tier is very high. So we'll drill in, we'll look at the key metrics, and we'll see that, okay, response times, some of the request times, yeah, it's been fine for a period of time, but something is not quite right, and it could be to do with this here. Application failure, quite a lot of times, so 179 failures. There's some SQL notation in there, maybe it's something to do with that. Let's explore that. Let's show the parameters. And if we expand on some of this and see just what's going on, and let's scroll down a little bit, we can see that actually this is where the exception timeout expired. There's a problem here, server not responding, and this is the code that's getting executed here. So this is the code that's ultimately where our problem is stemming from. This is enabling me to say to the developer, look, the application's having a problem. Stop pointing your finger at me saying it's the development environment, environment it's running in on virtualized platform. Instead, it's actually focused on, look, this is where the problem is very specifically occurring. Our monitoring tools are helping us understand that. And rather than just copy and paste this into an email, I think it'd be great if we could connect that with Visual Studio and raise it as a work item that allows organizations to, and the dev team to specifically see in their own language what's occurring, what's happened, and where I can go to find more information. So that was an extremely quick view at just how we can connect in DevOps. We're opening that conversation. Application owners say, my app is running slowly, what's going on? But the network looks fine. Ops manager says, great. The code passed, it was all fine when we tested it, great. The servers are running fine, that's running this particular application, great. But when we drill in and we start to look at perhaps the end user experience side, we can see that, okay, server side is fine. Client side, however, there's a problem. So something's slow at response time, something's not configured correctly, and it relates to that dinner now application that you broke earlier. So we're seeing that our application performance monitoring within Ops Manager helps us to pinpoint exactly where the issue is occurring. And as we showed, connecting with DevOps, we can start to link that and showcase and provide useful information and visualization to our dev teams about what's occurring, what's happened, where the specific, at the code execution level, what's going wrong. From both the server-side perspective, methods, parameters, variables, to a client side, load times, response times, JavaScript exceptions, and so on.
And this is going to eliminate a lot of finger pointing, a lot of back and forth that we hear happens between our IT departments, right?
Exactly.
Whose fault was it? But this could really give you a programmatic answer. Your fault.
Yeah, your fault.
So it always gives you a programmatic answer as far as, where that underlying problem really does lie. And so hopefully, again, our intention is to free up your time, stop troubleshooting this stuff, stop creating reports, stop running tests manually. Let's automate it, free up your time, and then we're going to automatically assign those bugs back to the developers as well. Correct,
and that's true. But we can also, once that has happened, like Simon was alluded to earlier on, at the end of the month, when you're looking through your reports of how many alerts have been raised for a certain system or website or whatever, we can start to trend and report on, for instance, the top 5 failure reasons for a certain application. So it allows us to drill in and see that visibility, even though this is a virtualized app running on the platform. Now, you say, well, I'm more concerned with virtual infrastructure. I manage the fabric, and it's the granularity that you can also apply to those kind of monitoring situations as well. We're just using the case of how granular it can go in an application perspective. So I think we've talked a lot about service delivery. You've talked about automation. You've talked about activities and runbooks and how those activities and runbooks integrate with the data bus, which is how Orchestrator passes its information between different components of the system. And there's a load of these activities out of the box. So get web server, whatever it may be, write web page, query XML. These are some examples of utilities, but it could be create VM in vSphere. There's lots of different activities that are out of the box within Orchestrator. We saw the designer earlier on in Simon's demonstration, how that enabled us to gather information, get an activity, create an incident, test dinner now. This is slightly more complex than yours. This is taking it to the next level, test the application, reset the web server, a couple of extra bits. But that's the beauty of Orchestrator, is it allows us to drag and drop and extend, and all of this data that's passing between these activities is running along that data bus. And there's 20 plus integration packs for Microsoft stuff, System Center tools, and third party. And it allows us to really deliver a rich and intuitive environment that lets us do things like system commands, schedule activities, send email notifications. So that was a simple one that alert admin could have been send an email to such and such a person to get a notification that that's happening. And when we think about the Runbook Designer, as we've said, lots of different packs available for you to use, from previous versions of System Center to the new versions of System Center. But you can also build your own. So within each of these activities, you can create custom ones, custom integration packs that are specific to your environment, that may have certain aspects that are relevant only to you. And we can build that automation in. So build them, take advantage of the Orchestrator integration toolkit to build your own automation integration with Orchestrator. So things like run.NET script, run program, run SSH command. It just enables you to pretty much control anything from within Orchestrator. Anything that's got an API that we can plug into, we can really extend and really start to do some cool stuff from an orchestration perspective. And it's pulling information from all over the place. So we're integrating all of these System Center components, VMM into Service Manager, Ops Manager into Service Manager, which is pulling all of the information about servers, clients, hardware, everything Ops Manager knows into Service Manager. Config Manager, all of the collection about client stuff, primary users, software that's on laptops and desktops. AD, users, groups, computers, preset parameters, printers, whatever it may be. And then Orchestrator is integrated in there as well to provide a more comprehensive integration with third-party tools. But Service Manager is that centralized source, that CMDB, and it's using Orchestrator and its integration there to provide some pretty compelling runbook automation. And if I've just got a simple CSV list of my printers or certain things within my infrastructure, I can import them as well. So it's not just about having a connector, if you will. We can import CSV-based data as well. And that's across the infrastructure. So Orchestrator and Service Manager working together to pull all that information into the CMDB, some of it through Orchestrator, to issue commands to other tools. So Service Manager triggering Orchestrator to run a workflow to fix dinner now was a good example that Symon went through before. All of this stuff is just built in the box with System Center. You integrate the two through simple connectors and it's done for you. And using the Service Manager data warehouse, collecting all of this information and reporting, we can build rich reports and repositories and dashboards that you can then use to provide back to the business. This is where VMware starts to fall down a little bit because some of those tools that they've acquired aren't as well integrated at this point in time, not like System Center and what we delivered in 2012 and SP1. And ultimately, and this is where we'll wrap up for a break, it extends beyond the private cloud. We saw earlier with App Controller how we connect not just to on-premise stuff, but also we can connect to Azure-based private clouds. We can connect to other infrastructures that are delivered by service providers, and we'll explore more of that later on as we explore hybrid infrastructure and so on. But for now, I think it's a good time to take a break. We want to give you a break. We need a break. You need a break. So I think we'll wrap for a little while, and we'll come back to resume shortly after.
We'll see you shortly. Thanks, Matt.